superposition of wave includes the standing wave and beats. Okay? Interference of wave, you can say that you can put the light on. That's right. It's okay. So this superposition of wave has better name, that is called interference of waves. Okay. If we want to discuss interference of two waves, then we'll be discussing the general case first and some special cases to be discussed. Let us complete the mathematical treatment of superposition of two waves. Okay? Just a minute. Yeah. Equation of progressive wave. Last session what we did? Equation of progressive wave. Hope all of you remember. Okay? The equation of progressive wave, as you have seen in the last class, we have taken it this way. I just remind you, y equal to a sin omega t minus kx. Remember this? Y equal to a sin omega t minus kx, or you can write kx minus omega t. It's up to you how you write it. But now we are going to consider, and we have seen that all the waves we can represent by using trigonometric curves, because it's a trigonometric term, we can use trigonometric curves. So let us assume that let two interfering waves be y1 equal to a1 sin omega t minus kx, and the other one is y2 equal to a2 sin omega t minus kx plus 5. Okay? Now, these two waves in a medium will superpose. There must be some principle. What is the principle? That is Huygens principle. What is Huygens principle? If two independent waves reach at a point in a medium, then resultant displacement of a particle is the algebraic sum of the displacement it suffered due to each individual wave. Okay?
In the medium?
So, if two interfering waves reach or interfere at a point in a medium, then the resultant displacement of a particle is the algebraic sum of the displacements it suffered due to each individual wave. Okay? Actually, this is true for two or more interfering waves, maybe more than two, maybe more than two waves are involved or are interfering. It may happen. So, according to this principle, if we focus on interference of two waves, then by Huygens principle, we have y equal to y1 plus y2. This is a common observation. If at a point a wave takes the particle in upward direction, when it goes this way a pulse, and another wave also taking upward direction, then resultant displacement will be what? Just sum of these two displacements. Okay, this is a fact. So y equal to y1 plus y2. So let us add these two. Now adding 1 and 2, from 1 and 2, a1 sin omega t minus kx, a2 sin omega t minus kx. I'm just expanding sin a plus b. Yeah? a2 sin omega t minus kx cos phi. Just open the term sin a plus b using that. This plus cos omega t minus kx sin phi. Okay? So y equal to you take this thing common, a1 sin omega t minus kx only common. Then what will you get? a1 plus a2 cos phi sin omega t minus kx plus, just opening the bracket, a2 sin phi cos omega t minus kx. Hope you all have understood. There is no difficulty in it. We have just simply used sin a plus b rule. Okay? But where we want to see in terms of a single sine or cosine term. So our effort will be accordingly. In this equation number 3, this expression, we are taking, let a1 plus a2 cos phi. What phi stands for here? You all can understand phi is the phase difference, isn't it? Just observe these two equations. Phi stands for what? Phi is the phase difference. Okay? Now we are assuming this thing as a cos epsilon and a2 sin phi as a sin epsilon.
Simulation করা যায়?
Yeah, I just assuming because our aim is to express in terms of one sine or one cosine. Any term, A is there, no? You cannot say only cos epsilon, then it will be wrong. But if you write A cos epsilon, then it's fine. Then y going to be what? A omega t minus kx cos epsilon plus cos omega t minus kx sin epsilon. It's alright? Or y equal to, we are writing this way, A sin omega t minus kx plus epsilon. Okay? So this is our resultant waveform. In this resultant waveform, what is your observation? If we add these two terms, what do I get? From, we need to find the value of A, we need to find the value of epsilon. This is mathematical way. How to represent this by vector diagram, that I will show you. And then I will show you how to represent this by actual wave formation. Okay? So from 4 and 5, what is my aim? See, my aim is to calculate this value of A and this epsilon. How will I get? From 4 and 5. No, 6 is there. This is number 6. This is 4 and 5. Squaring and adding. What do I get? A1 plus A2 cos phi whole square, A2 sin phi whole square, A square cos square epsilon sin square epsilon. Agree or not? So this implies A1 square cos square phi sin square phi. So A is going to be what? Twice A1 A2 cos phi. Just keep in your mind, just think whether you have seen this kind of term before or not. You have seen in vector addition. And we are interested to get the value of epsilon also. Again from 4 and 5, what do you get? Dividing 5 by 4. A2 sin phi by A1 plus A2 cos phi will be equal to tan epsilon. This also we have seen. Epsilon equal to tan inverse A2 sin phi by A1 plus A2 cos phi. Okay? Clear? This is number 8. Now, this we have seen in vector addition. Two vectors, their magnitudes P and Q, acting at an angle phi, resultant given by this, resultant displacement, velocity, whatever you say, and the resultant makes this much angle with A1. Am I correct? Q sin theta by P plus Q cos theta. Remember it. So if somebody says that, can't you go back there? Can't you add these two by using vector diagram? Of course you can do. That has better name. That is called phasor diagram. And this phasor diagram helps a lot. We can avoid mathematical complexity. How to? I just explained. You are going to add these two. By now, you will follow this method only. You are going to add these two waves. Okay? These two waves. How can you add? Hope waves equation are with you. I am adding these two. Huh? See the procedure. What I am doing there, first vector I am adding here. The first vector is having magnitude A1. Going to use what? I'll tell you what. Second one has amplitude, displacement A2. Isn't it? What's the angle between A1 and A2? Phi. So take this way. So far, what you have done here? AB is vector A1 amplitude. From B, you have taken BC, whose amplitude is A2. And this angle phi you have taken. If I imagine there are two vectors A1 and A2, angle between them phi, then resultant vector is the third side of the triangle, that is called triangle law. So this will represent a resultant. This is what? A1 square, A2 square, 2A1, A2 cos phi. Clear? And what is the angle here? This makes an angle how much? Epsilon. And tan epsilon, see, like vector only, that's why you dare to do it, no? Is A2 sin phi, that divided by A1 plus A2 cos phi. Alright? So, if you can find the third side, length and direction, then it is over. Now, let me tell you what to do with three vectors. If three vectors are there, how to find the resultant? Just extension. For three vectors, what to do? Take one this way, the other one this way, third one this way, A1, A2, A3. What principle you are following? This angle be phi 1, this angle be phi 2. Then what? By polygon rule. This is the resultant. Am I correct? So, whatever number of waves are interfering, you can use this principle. Obviously, this part covers your competitive exams. They will not ask you superposition of 3 or 4 waves or more than that in your school exam. Got the point? So, for 2 waves, keep this thing in your mind, but 4 waves or 5 waves or more will be using polygon rule. Let me ask you 2 definite problems on this first. Okay? To understand this thing, just write, add the following waves. Number 1, or better you put this statement, A particle is subjected to the following displacements simultaneously. Find the amplitude of resultant vibration. Find the amplitude of resultant vibration. Which three waves? I am giving you three waves here. Y1, A sin omega t, Y2, A sin omega t minus pi by 4, Y3, A sin omega t minus pi by 2. Let us solve it completely. Then we will go for wave with, resultant of 4 waves. Let us solve it first by using phasor diagram concept only. Okay? Y1 is A sin omega t. Only you are finding amplitude only, not angle. Angle you will do later. Same thing. So what we will do here? First one, take horizontal. What's the magnitude over there? You know, A. A is the magnitude, no? So we have taken that manner. So this you take AB. AB is representing A. Next one is how much? Omega t minus pi by 4. Will you take anticlockwise or clockwise sense? Anticlockwise angle is positive. Clockwise angle is negative. So we must take it this manner. Wait, all these things I am writing afterwards. Let me take this angle as pi by 4. Which one? This angle as pi by 4. If it is pi by 4, then I have taken rightly. This one A, this one A. Third one is how much? From here difference is again pi by 2. So it will be like this. You agree or not? Third one will make further an angle pi by 4 with the second one. So this is pi by 4. So Lm representing first wave amplitude, Mn second wave amplitude, they are all vectors, and then Nr. Then how will you get? You can get this manner. I think all of you can get it quickly. Isn't it? Lr can be found. Lr is the resultant. They asked you to find the resultant amplitude. So draw a perpendicular here. Just go by any method you like. Need not follow the way I am doing here. Ns. So we will find Lr. What is Ms? A cos pi by 4, A by root 2. What is Sn? A sin pi by 4. That is also A by root 2. Correct? So, when you are going to find Lr, I am doing it with the help of geometry, plain geometry. Huh? Lr will be what? Ls square plus Sr square. What is Ls? A plus A by root What is SR? That is also isn't it? So you can take A square common, this plus so A root 2 1 plus 1 by root 2 A into root 2 plus 1. Am I correct? Done? The value is A into root 2 plus 1 resultant amplitude. Can you tell me the angle very first? You can, isn't it? This is also pi by 4 from diagram only. Epsilon is pi by 4. Okay? Now I am asking you one sum which you will practice yourself. You must try, you must finish it before I do it here. Just write. Due to arrival of 4 waves, a particle has the following displacements. Due to arrival of 4 waves, a particle has following displacements. What are those? y1 equal to 5 sin 3140, y2 equal to 3140 minus pi by 2, y3 equal to, this is omega t, don't be confused, minus pi, and then y4 equal to 2 sin 3140 minus 3 pi by 2. Question is, find the amplitude of resultant vibration. Do. Just start the same manner. Start the same manner. Y1 is 5 unit. First one always take horizontal. Huh? 1, 2, 3, 4, 5. Next one minus pi by 2. So you should take clockwise sense. 1, 2, 3, 4. This is RS T. Next one, how much? 3 unit. And differing phase by how much? Pi by 2. You understand? This is pi by 2.
So from S to T you have taken 3 units.
Yeah. No, 4 units. S to T 4 units is given now. Second wave 4. First wave 5. This one 3 units. Clear? Tu is C. Again it will turn by pi by 2. By how much? 2 units only. This is bit problematic. But I am sure it will point towards this only. Little bit trigonometry, a little bit geometry sense will tell you that if you extend it, ux, then it will net r. Isn't it? How to find resultant now? Which rule you are going to apply? This is first, second, third, fourth. You get the resultant only. Just join this. Acha, I did a mistake over there. Can you find? This is pi by 2, no? Not pi by 4. You could have told me. This is pi by 2, so it will go this manner. Pi by 2, no? 2 units this way. More prominent here. This is ux. This is ux. So your problem is to find the resultant, which is Rx. This thing. It's very easy. This is 3 unit means this part 2, this part 2. So this is going to be, that is 2.84. Done, resultant amplitude. And since this one to epsilon going to be what? Epsilon means that phase difference with the first one, resultant in this one, pi by 4. I hope you have understood. Is it okay? Now we are going to do superposition of two waves to produce standing wave. Okay? Standing wave. Continuation of the topic. Two progressive waves are traveling. Just little bit graphical presentation I will show you. One wave going towards right, okay, and the other one is coming towards left. My diagram is never perfect. I regret. This wave traveling towards left. This is towards right, this one towards left. These two progressive waves, when they approach each other from two opposite directions, they give rise to a system which is alternately vexing and veining. Or shrinking and expanding. Shrinking and expanding. Sorry. shrinking and expanding, but not traveling in either direction. Okay? Switch off and keep in bag. No. Keep in your bag, please. Don't open it. So when two progressive waves traveling along the same medium, same straight line, but from opposite direction, then due to their superposition, they give rise to a system which is alternately shrinking and expanding or waxing and waning, but not traveling in either direction. That is called stagnant. So I have showed you how to write this equation. This one is y equal to what? A sine, remember it, I hope, and they are of equal wavelength and amplitude. Then only standing wave will be produced. This is y1, and y2 you take A sine, right to left, no? Let two interfering waves be like this. y1 equal to A sin omega t minus kx, y2 equal to A sin omega t plus kx. Now, to study the nature, what we have to do? We have to use superposition principle. So apply the superposition principle. Y equal to y1 plus y2 A sin omega t minus kx here. If you go by this physical observation, what will you observe here? If they are of equal amplitude, at this point resultant waveform what kind? 0, 0. This one take a distance down, this one take, second wave take a distance up. So resultant amplitude going to be equal to 0 forever. 0, 0, 0, 0. But this is when? This is when this you have taken, say, time t equal to 0, this will happen t equal to t by 4. 1/4 of the time period is over. Then what will happen? Then the resultant waveform, if you draw, say in time t equal to 2t by 4, what will you observe? Achha, this you take t equal to 0. Initially they have interfered that manner. This you take t equal to t by 4. T equal to 0 only because of their superposition, they are equal and opposite, no? They get cancelled. So resultant displacement is like this. When t equal to t by 4, what do you observe? Resultant waveform. The pattern will be like this. It might have moved. The first wave might have gone this manner. Okay? Second wave might have gone that with the yellow one, if we draw, time is different, no? This is the second wave, dotted one. This is not A, this is not A, less than that. So what kind of resultant waveform we will get? the resultant waveform will be like this. Now you can see that starting from beginning, these points where they interfere, the particle has no displacement, this point with this point. Permanently they are at rest. This is the point. Although this is not matching, I have to take it little bit leftward, and this is the disadvantage when you are doing it by hand. Little bit leftward, if I move, then it's fine. Wait a minute, I will do. Little bit, yeah. See this point, what is happening there? Yeah, this point, this point. This point. Here also particle not moving. Similarly, points are there, not particle moving, particle not moving. So these are permanently at the state of rest. These are called nodes. Okay? And at some point, particle suffer maximum displacement. Those are antinodes. Coming back to that point, let me explain this mathematical part first. How this one formed, try to understand. So if you add these two, what will happen? You can take the wave this manner also. Y equal to, if you like, A sine 2 pi by lambda Vt minus x. Remember, this form of wave also we have taken Vt plus x. So here, if you add these two, what will you get? A into sin c plus sin d. Sin c plus sin d is what? 2 sin c plus d by 2 cos c minus d by 2. Understood? Twice a cos kx sin omega t. Okay? This is the resultant waveform. And very peculiar. See, this one, this sine and cosine terms, these are called periodic functions, no? This is the equation of standing wave now. This standing wave has double periodicity. This standing wave has double periodicity. Why it is said that? This is a standing wave. It has double periodicity. Why? Because two periodic terms are involved. This is a periodic term. This function is periodic. What are those? Periodic means the graph repeats in a fixed interval, isn't it? So it has double periodicity. In the language of physics, you can say that this expression on left hand side, y vanishes twice. Once due to cos kx and then due to sin omega t. That is why the standing wave, this is the equation of standing wave, no? Standing wave is said to have double periodicity. Okay? Clear? This equation you all have understood? Can you write in terms of omega and in terms of lambda and v? What k stands for? We did it last class. K equal to 2 pi by lambda. This is called what? wave number. Omega is 2 pi by 3. So you can write this way also. So I say cos 2 pi by lambda into x sine what? Two pi by 3 into t. Two pi by 3 into t, or you can write this way also. Sine. Don't be confused. That's why I'm writing twice. No, otherwise this equation is enough. Mathematically, we have added just and told it has double periodicity. Now, what you can do there, if we consider as it is not moving, so at a particular position of the medium, the value of k is fixed, value of x is fixed. So at a particular position, x fixed, t is not, time will pass, no? So we can write the equation in the form y equal to a sine omega t, where a equal to what? Twice a cos kx. It is a function of distance. If you keep distance fixed, the whole thing will be function of time. Okay? Now, with time, what will happen? Have you ever seen this kind of waveform? Have you seen it? But if you think, then if you start thinking about this, where it is possible, you must have seen in case of stretched wave and in case of fluid. Why? That I will explain, not easy to understand now. Just let me show you this diagram now. Yes. The diagram we are struggling with, go there, go back there. Which diagram we are seeing here? This formation of standing wave we are doing now. Then I have told you that some points are there where particles are not moving. Those points are referred as nodes. Some points they suffer maximum displacement, that is antinode. Now, with time we have done up to t equal to t by 4. 2t by 4 what will happen? 3t by what will happen? That we have to see. What will happen in time 2t by 4? Just check. Achha, let me change the mode. I have to. Just a minute. Just a minute. Technical glitch. Yes. So that stationary wave from the equation y equal to a sine omega t. What's the value of a? Tell 2a cos kx, isn't it? With time, the interference of two waves at time when t equal to complete time period is over, then the shape of the graph will bring back to the original state like this. That lower one will go up, upper one will come down. The resultant waveform we can bring in terms of this. Unfortunately, I have to change the board. I cannot draw the reference point. And this will observe in case of string, in case of fluid it happens, that we have to assume. These are the points where particles are permanently at the state of rest, and these are the points where it suffers maximum displacement. A is maximum when? A is maximum when? When A is maximum? When cos kx is equal to plus or minus 1. Isn't it? Maximum means those are antinodes. This is n pi. So x will be what? N pi by k. What is the value of k? 2 pi by lambda. So this will be n lambda by 2, xn. So x0, x1 is what? Lambda by 2. x2 is what? Lambda. x3 is what? 3 lambda by 2 like this. So distance between two conjugative antinodes is what? Tell? Lambda by 2. Okay? And lambda value if you substitute, lambda can be expressed in terms of 2 pi, but we are not doing it. Just write lambda by 2. For maximum, this is okay. For minimum, what will happen? Tell. For minimum, cos kx should be 0. So kx is 12 plus 1 pi by 2. Okay? So x in dashed I am writing 12 plus 1 pi by 2 by k. K is what? 2 pi by lambda. So this will be what? 2n plus 1 by 4 into lambda. Okay? So these are the points for what? For minima, what will happen? For minima, nodes will be formed. So write the distances now. x0 dashed is what? Lambda by 4. x1 dashed 3 lambda by 4 like this. So therefore distance between two consecutive nodes is also this minus this is what? Lambda by 2. Okay? So, distance between two nodes equal to distance between two antinodes is equal to lambda by 2. So this is symmetric, no? It will be destroyed over there, but graph will be symmetric, the way I was plotting here. This pattern you will find where? This will find vibration of stretched wave. So next topic we are going to do formation of transverse standing wave. Transverse standing wave, where it is formed. Rigid walls are there and an uniform rod is tied between two opposite walls. Okay? This is a rod of length L. This is tied between two opposite walls or two opposite supports. How can you form one wave going towards right and then coming back? This is possible due to reflection only. How to get it? This you can get when the string is stuck at the middle. And we get first mode of vibration. So let me write first mode of vibration. What will you get there? This rod will vibrate like this. Node here, because not free to vibrate, no? An antinode there. When you just stuck at the middle, then first vibration will be like this. First mode of vibration. So, what's the distance between two nodes? Now, just we have seen it is lambda by 2. But how much was given there? L. So, lambda equal to 2L. What's the frequency of vibration? N0, the frequency of vibration will be what? V by lambda. V we have seen before. Last class we have solved sums. So N0 is 1 by 12 root 3 by mu. This is called frequency of fundamental tone or first harmonic. Frequency of or first harmonic. Okay? Let us go for second mode of vibration. What will happen there? Stuck at a distance 1/4 from left end. People have seen this, no, for a long time. Same rod I am taking here. You'll observe this kind of vibration. It will vibrate in two loops. Frequency will be more or less. Can you answer? This length, more, it will be more. More loops, more frequency. That we are going to prove. Here frequency is this, so it will be double of that. Here, L will be what? Oh, lambda by 2, no? Not 4. Distance between two consecutive nodes. So lambda. Therefore, N1 equal to V by lambda, V by L, 1 by L root over. Therefore, this is 2N0. Second mode we got 2N0. Third mode you tried before. And how will you name this? We have to name this one. It was the first harmonic. This is second harmonic or first overtone. Same thing. Second harmonic or first overtone. Go for next one where 3 loops are there. This you can do, I'm sure. You finish it before I do it here. There will be another loop, nothing else. Three loops. Always node at the end. Why node at the end always? Any reason? Because ends are not free to vibrate. So nodes at the end. More loops are there. So L going to be what? Lambda by 2. This plus lambda by 2. So it is. So L is what? Lambda is what? So N2 is what? V by lambda, same thing. Root 3 by mu by 12. So this is 3N0. So how will I refer this? Frequency of third harmonic or second overtone. Overtone, note, overtone. Therefore, for n loops, for nth overtone, you write the relation for or pth overtone, this happens in second overtone, isn't it? So for pth overtone, what will happen? Np equal to p plus 1 n0, where n0 equal to that fundamental tone frequency, f by mu or t by mu. Clear? Understood? So this is general relation. Never forget, for pth overtone. If I have asked you for pth harmonic, what's the formula? Instead of pth overtone, if pth harmonic is there, what will the answer?
P plus 2N.
No, no, it will be n0 simply. See, no, third harmonic 3n0, second harmonic 2n0. So pth harmonic how to write the symbol? Just write Np equal to Pn. Bus. Change the symbol if you like. Okay? Now, when you are solving problem or theory question asked, you might be confused with few terms. That I am telling you. What is a tone? What is a note? What is a fundamental tone? What is a overtone? And what is harmonic? You can write just one line statement. What is tone? Tone means sound wave consists of one frequency only. What is note? Sound wave consists of several frequencies. That is what? My voice, best example. My voice has several frequencies. Human voice.
So playing one key on the piano?
Piano you can, many frequencies can be obtained.
So if you only play one key.
One key is one. Here the best example, tuning fork. Okay? Tuning fork, only one frequency. Tuning fork. Now, what is harmonic? Or what is overtone? First you write its frequency greater than frequency of FT. FT means fundamental tone. It has least frequency. Fundamental tone has least frequency. Out of these tones, fundamental tone has the least frequency. For a harmonics, whose frequencies are integral multiple of the fundamental tone. That is called harmonic. Okay? Done? So now, if somebody asks you a question, explain the statement, all harmonics are overtones, explain the following statement. What is that? All harmonics are overtones, but all overtones are not harmonics. It's very simple. The harmonics integral multiple. But if the lowest frequency is 17, 34 is harmonic, 51 is harmonic, 16 is harmonic, but one of them is 42. 42 is what? This is not harmonic. It is not integral multiple of 17. So it will be overtone. So harmonics have frequency larger than the fundamental tone, that's why they are overtones, confirm. But overtone need not be integral multiple. That's why they are overtones. Clear? This completes today's first session. Okay?